Hi friends, welcome to B.Tech. In the last session, we have discussed Unit 3 in power system analysis, right? So in this session, we are going to discuss Unit 4 in power system analysis, that is symmetrical fault analysis. Okay? So before going into our unit, symmetrical fault analysis, let us we see the syllabus in Unit 4, and after that we will have some introduction about Unit 4. Okay? Then we will go into our syllabus one by one. Okay? See here. So Unit 4 is symmetrical fault analysis, right? So what is the syllabus in symmetrical fault analysis? See here. First one is transients on transmission line. That is, we know that we have a transmission line where we transfer the electric power, right? So in transmission line we have resistance and inductance and shunt capacitance like this, right? So this is the transmission line. Okay. If we connect this transmission line in a power system network, okay, if a short circuit occurs, what will happen to this transmission line? And what is the current flowing in this transmission line? Okay. That is about the transients on a transmission line. Okay. And next is short circuit of synchronous machine. That is, after transmission line, we have a synchronous machine is present at the end of the receiving end station, right? That is synchronous generator. Okay. Synchronous generator is present, where from that synchronous generator we will transfer the electric power by using the transmission lines, right? So what will happen if a short circuit occurs in a synchronous generator? Here we have two conditions, that is on load and on no load. What will happen when a short circuit occurs in a synchronous machine? Next one is three-phase short circuit currents and reactances of synchronous machine. That is, means here symmetrical fault means it is the fault related to three-phase short circuit. Okay, so we will see what are the currents in whenever a three-phase fault occurs. Okay, in power systems. And short circuit MVA calculations. That is, what will be the MVA rating, means what happened to the MVA rating of a machine if a short circuit fault occur in a power system network, that we will see here. And series reactors, selection of reactors. We use reactors for reducing some of the internal faults occur in the machine or in the transmission line, and we will see that here. And selection of reactors is also important. That is, what type of reactors that we have to use in power system network in order to reduce the fault. Okay, so these are the topics comes in symmetrical fault analysis. And now we will see the introduction of symmetrical fault analysis. That is, what is fault and what is the use of fault calculations and other types of faults. Okay, that we will see here one by one. And see, a fault in a power system, that is, a fault in a power system or circuit is a failure which interferes with the normal flow of current. That is, in a power system, if you have a transmission line or if you have a synchronous generator, suppose the normal flow of current is 10 amperes, if a fault occurs or if a short circuit occurs, the current flow will become nearly 100 amperes. That is, see, in the normal condition, the current flow will be 10 amperes. If a short circuit or a fault occurs in a power system, the current flow will be nearly 100 amperes. See, I am assuming it as 100 amperes. It is not exactly 100 amperes. Okay, for your understanding purpose, I am taking it as 100 amperes. See, in a normal flow we have 10 amperes. Whenever a fault occurs in the power system, the current flow will be 100 amperes. Means, see here, it is nearly 10 times, right? Nearly 10 times of the normal flow of current. That is simply called as a fault. Okay, so that is what I am explaining you here in this point. See, a fault in a power system or circuit is a failure which interferes with the normal flow of current. Okay, that is the meaning of this. Okay, and next point is here, the faults are associated with abnormal change in current, voltage and frequency of the power system. One more important point regarding the faults is, if a fault occur in a power system, there will be a change in not only in the current, in voltage and frequency also. Okay, that is the main point we have to study here. That is, if fault occur in a power system, we all think that there will be an abnormal flow of current in the power system. But moreover, another one is another disadvantage occurring of fault in the power system is there affects the voltages and frequency in the power system also. Okay, and next one is, in general, fault occurs in the power system networks due to, see, insulation failure of equipments. So generally in power systems we come across the alternators, we come across the circuit breakers, relays and transmission lines, right? For each and everything we require insulation material. A fault occurs in a power system, The first reason why the fault occurs in a power system means because of the insulation failure. Okay, installation failure of equipments. Okay, that is the first occurrence of a fault in a power system. Okay, and next is flashover of lines initiated by a lightning strokes. It's a common fault in power system for mainly for overhead transmission lines. See here, if you have a transmission tower like this, so most of the transmission lines will be like this only, no? Overhead transmission lines. Whenever lightning occurs or whenever thunder falls on these transmission lines, what will happen means there occur the short circuit between the thunder and the transmission line, and there the amount of flow of higher means there is chance of flowing of high amount of currents. Okay, that is the one of the reason for occurring of faults. Next one is due to accidentally fault operations. Suppose here accidentally faulty operations means whenever transmission lines get short circuited, whenever birds or any other animal get struck with the transmission lines or transmission towers. Okay, those are some of the faulty operations. Okay, so because of these, faults are occur in the power systems. Okay, and what is the need of fault calculations? Why we have to calculate the fault current? So what is the use of fault calculation means? See, if you are using transmission lines or if you are using alternators in the power systems means we need to calculate how much of current it has to withstand, right? So without calculating the fault, without calculating the fault currents that the equipment can withstand, okay, we shouldn't use those equipments in the power system. Okay, that is simply if you take a circuit breaker. If you want to use a circuit breaker in a power system network, okay, before that we need to calculate the amount of current that a circuit breaker can flow through it. Okay, so without calculating the fault current, okay, it doesn't use the equipments in a power system. So what is the need of fault calculations means here? See, when the fault occur in a part of a power system, heavy current flows in that part of circuit which may cause permanent damage to the equipments, right? So whenever a fault occurs in a power systems, what happens means sometimes circuit breakers save the equipment from the faults, but in some cases like small devices will affect with the fault current where it gives a permanent damage to that equipment. Okay, and next one is the selection of the circuit breaker depends on the current flowing immediately after the fault occurs. See, if you are designing a circuit breaker means that is what I told you now. If you want to design a circuit breaker means we need to know the how much amount of current that it can flow through it. Okay, the estimation of these currents for various types of faults at various locations in the system is called fault calculations. That is at various locations means from generating station to the receiving end, that is to the load centers, we have come across the primary transmission, secondary transmission, primary distribution and secondary distribution, right? So we come across all these things. So among these four, if a fault occurs means we need to reduce that fault. Okay, if you are unable to reduce that fault means the total effect will be on the load centers only. Okay, that is the reason why we have to reduce that fault whenever it occurs in a transmission or in a distribution. Okay, and next one is the data obtained from fault calculations are also used to determine the settings of the relay which control the circuit breakers. See, suppose if you have a relay like this, and a circuit breaker is like this. Suppose if any fault occurs in the power systems, this relay senses that fault and it sends a signal to the circuit breaker. A fault is occurred in the power system. Then the circuit breaker will trip the circuit from the faulty conditions. Okay, that is the order of protecting the circuit from the faults. Okay, that is in a fault calculations we have to mainly concentrate on how much amount of current that flows through a circuit whenever a fault occurs. That is first one, and second one is we need to design a circuit breaker where how much amount of current that it can flow through it, and second one is relay also, design of relay also. Okay, that is the need for fault calculations. And next one is we will see the types of faults. Types of faults means see generally faults can be broadly classified into two faults. What are those means? Shunt faults. The another name for shunt faults is short circuit faults. Okay, first one is shunt faults. The another name for shunt faults is short circuit faults. So next one is series faults, or these series faults are also called as open conductors or open conductor faults. So we have two types of faults. So first one is shunt faults. and the other name for shunt faults is short circuit faults, and next one is series faults. The another name for series faults is open circuit faults or open conductor faults. And we will see what is shunt fault. Okay, shunt type of faults involves short circuit between conductor and ground or short circuit between two or more conductors. That is, we know that we have three-phase transmission, right, in overhead lines. So if you have three-phase power transmission like this, R, Y, B, and it is a neutral. If you have a short circuit occur between two transmission lines, two conductors, okay, then it is called as a short circuit fault. And if we have a short circuit occur between the line and the neutral, it will be also called as a short circuit fault. Okay, so whenever a short circuit occur between the two lines or between the line and a conductor, then those faults are called as the shunt faults. And how we identify that fault to the shunt fault means it is identified by based on there in the shunt fault there will be increase in current, fall in voltage and frequency. So based on these three characteristics we can identify that fault is a shunt fault. That is, whenever we have an increase in current and decrease in voltage and frequency, then the fault is called as shunt fault. Okay, and next one is series faults. Series faults means, suppose if you have a conductor like this, whenever a fault occurs, the conductors will get open circuited like this. That is, the conductor will be like this. So these type of faults are called as series faults. Okay, and how we characterize it or how we identify that fault is a series fault means there will be decrease in current but increase in voltage and frequency. Okay, decrease in current and increase in voltage and frequency. That's how we identify a series faults. So now faults are broadly classified into two types. First one is short circuit fault, or the short circuit fault is also called as shunt faults. And whereas series faults, those faults are also called as open circuit or open conductor faults. Okay, how we identify or how we characterize a shunt fault is based on the increase in current and decrease in voltage and frequency. And whereas a series fault can be characterized based on decrease in current, increase in voltage and frequency. That is how we classify the faults. That is shunt and series. And now we will see what are shunt faults or what are series faults. Okay, and see here we can broadly classify. This is the network diagram, means how the faults are classified. See, shunt faults and series faults. See, under shunt faults it is again classified into symmetrical faults and unsymmetrical faults. Okay, symmetrical faults and unsymmetrical faults. Whereas a symmetrical fault is a three-phase fault. That is, whenever we have a short circuit occur between the three phases, then that fault is called as three-phase fault, or it is simply called as symmetrical fault. Okay, and whenever we have a fault between line and ground, that is, if you have a line or line and if you have ground wire like this, so if a fault occur between line and ground, then it is called as line to ground fault. Okay, line to line fault, that means if you have fault occur between two lines R and Y, then it is called as line to line fault. And if you have a fault occur between two lines and a ground, that is R, Y and ground, then it is called a double line to ground fault. That is, line to ground fault, line to line fault, double line to ground fault are classified or called as unsymmetrical faults, and whereas a three-phase fault is called as symmetrical faults. Okay, and moreover series faults are classified into two types, that is one open conductor faults or two open conductor faults. That is how we classify, or that is how we differentiate the faults in power systems. That is shunt faults, and again shunt faults are classified into two types, that is symmetrical faults and unsymmetrical faults. Whereas in unsymmetrical faults it is again classified into line to ground fault, line to line fault and double line to ground fault. And whereas a symmetrical fault is also called as a three-phase fault. And coming to the series faults, it is again classified into two types, that is one open conductor fault and next one is two open conductor faults. That is, see here, suppose if you have a conductor like this, so if one conductor is get open circuited like this, then it is called as one open conductor fault. Suppose if I have another line, Y line is also get open circuited, then it is called as two open conductor fault, like this. Okay, and next see here, occurrence of faults in the power system in the order of increasing is as follows. See, I told you that most of the faults in power system are short circuit faults, not open circuit faults. Okay, that is most of the faults in the power system where a overhead line subjected to only the short circuit faults, most of the faults. Okay, and among the short circuit faults, so three-phase fault occurrence is up to 5% only. That is, in power system over a transmission line, okay, three-phase faults or occurrence is nothing but 5%, and whereas a double line to ground fault occurrence is 10%, and line to line fault occurrence is 15%, and single line to ground fault occurrence is 70%. That is, so from among these four, we can conclude that means what is the most occurred fault in overhead power system lines, that too in short circuit faults, is line to ground fault. So line to ground fault is occurred mostly in power systems. That is nearly 70% of the faults. 70% of the faults in power systems are line to ground faults. Okay. And here one more point I want to tell you is, see, line to in power systems, line to ground fault occurs very frequently in power systems, right? And whereas a three-phase fault occurrence is very low in power systems. But the severity here, if you see the severity among these four faults, three-phase fault is a more severe fault than the line to ground fault. That is, if a three-phase fault occurs in a power system, the damage to the equipment or the damage to the power system network is very high. Okay, when a line to ground fault occurs in a power system, the damage is very low compared to three-phase. So the severity is very high in three-phase fault when compared to the line to ground fault. But the occurrence of the fault is line to ground fault in the power systems. Okay, and see here the various faults in the order of increasing severity. See here, severity is as follows. That is, open conductor fault, line to ground fault, line to line fault, double line to ground fault, three-phase fault. See, increasing order means increasing order. So in increasing order, if you go in increasing order, three-phase fault is the highest severity among the remaining other faults. Okay, that's it for today's session, and we'll meet again in the next session. Thank you.